So let's get started. This has been a long day. This is the beginning of a long week. So just give me, 20, 25 minutes tops and we're done. So around 4 o'clock or so, I'll start to finish this up. So let's get started. This is the section of sections. This is huge, huge. If you could see me, big wink face. Oh, that looks a bit creepy, but this is very, very important. That looks really creepy. I'm sorry about that. I'm trying to make a cute winky face, but doesn't work. If you can name an alkane, you can name almost anything in this course. And when I say name, the fancy word for name is nomenclature. So if you can name these guys, you can name everything in this course. Naming definitely gets harder when you move deeper into chemistry. So some of you guys maybe eventually will do a degree in chemical engineering if you want to, or something else. It gets a little crazier, but this is a good introduction. So naming alkanes, we are going to follow what's called the IUPAC and systematic naming system. Systematic is kind of how we will name these elements, molecules, how most people name them. We're not using old names. We're not using like stock names. We're using a systematic method of naming, and it really ties into IUPAC. If you can remember this from chemistry 1120 or 1121, this is the International Union of Pure and Applied Chemistry. So these are names that are accepted all over the world, everywhere. It's like the metric system of chemistry, of naming in this case. Compounds, so molecules, hydrocarbons, these are given a systematic naming process. It's really quite simple once you understand the process. Again, if you can name a couple of alkanes, you can name almost every alkane in this course. So the names are like a three-part system. They have a prefix, a parent, and a suffix. Now, this is not communications or English class, don't worry. Oh, sorry, my dog. Here's somebody outside. Hold on 1 second. I'll be right back. Anyways, sorry, okay, back to this. Prefix. Pre means before. So the prefix is in the name something that goes before the parent and the suffix. And again, this is not communications. You don't need to define prefix, parent, suffix. I'm just explaining the three parts of the name. So the prefix covers the substituents. You will very quickly learn what a substituent is. These are the things that stick off the chain. It's basically, they stick off the parent chain. And I'll explain this. You will see, I promise. By the end of the next couple classes, you guys will be professional namers. When I say stick off, I mean like branches, like a tree branch. It sticks up or down or away from the chain. The parent is how many carbons are in your main chain. You'll see this. It's pretty simple. And then the suffix is the family. And we'll see more of this in unit 3 and 4. The family are like alkane, alkene, alkyne. And it will even, like at the end of this course, the suffix, the family, will evolve into things like carboxylic acids, alcohols, ketones. So like when I say butanol, that means it's 4 carbons, but also it's an alcohol. Butanone is 4 carbons, but it has a ketone in there. And I need a little more information there. That is at the end of this course. So we don't have to worry about that for a while. So you can kind of think of the suffix as in like your last name. Okay, so it kind of defines who you are, where you came from, but then you are still you. You have other names that go with it. And this would be your first name, would be like your parent name. And then the prefix would be other names. Like for me, I have a first name and a middle name. So my last name is the suffix, the important part. You know, I am a Scaines, that's my last name. Um, Most importantly, I am Mark Scaines, that's my parent and my suffix. And I have a middle name, it's Stephen, if you're wondering. That would be like something not as important, but sticking off of my overall name. You know, when I say my name, I never say my middle name. So let's have a little look at this. The first step you have to do, and again, you guys, I know you're the chosen ones, as we call you. Most of my classes already know a lot of this. So I'll go a little quick because this is pretty simple. The first step when you name an alkane is to count the longest chain of connecting carbon atoms. You have to count from left to right or right to left. So this is like a mixture. It could be English, it could be Arabic. You know, in English we write left to right. In Arabic you write the opposite direction, I think. I hope I'm right there. In chemistry, we can go both ways, and I'll show you how that works. And Niam in the chat, it will hurt, but she'll get a loving family, I hope. And if she doesn't get adopted by a loving family, I'll keep her until she does. And if she never gets adopted, then I guess she's my dog forever. And this will be up on YouTube, so it's basically in writing. Okay, so this is not the best example because there's no branches, but this would be a continuous chain, and the green has nothing to do with the green is just me coloring in or highlighting the longest chain. This is an easy one of my favorite hydrocarbons, hexane. Hex because there's 6 carbons, ane because it's an alkane. Oops, that looks like an E, doesn't it? Ooh, that's bad. Everything in chapter 2 is an alkane. So everything in chapter 2 will end in the family A and E. That's the family. The parent is hex. So, Mark Scaines, hex, ane, that's your most important part. I guess my name kind of sounds like a hydrocarbon. Scaines sounds like an alkane, doesn't it? Anyways, okay. So here's the thing. This is a beautiful example in my humble opinion. There used to be some typos in my slide, and I hope I have them fixed, but if you see any mistakes, open your mic or let me know in the chat, because I fix mistakes as I go, but sometimes they slip through. And yeah, I do think I might be an alkane. I wouldn't mind that. Okay, so let's look at these 2 examples. One is correct, obviously, and one is incorrect. So, all right, I am a left to right person. You can go right to left, it doesn't matter for now. It will matter soon. But you have to start at a terminal or ending carbon. Like, I can't start counting in the middle. No, you have to start at the end. Okay, so I like to start on the left for now. I have 1, 2, 3, 4, 5, 6. Okay, and honestly, guys, if I went backwards, same thing. 6 carbons, this chain, left to right, right to left. This is a 6 carbon chain. Well, come over here to the incorrect side. What if I started here? 1, 2, 3, 4, 5. 5 is not as big as 6. So this highlighted in green is my longest chain. These guys are called substituents. Hard word to spell. And you know what? If you don't like calling them substituents, I'm just going to write subst with a T. They're just called branches. Oops, spelt that wrong, didn't I? It's been a long day. All right, branches. Okay, think of this like a tree and sticking off of the main limb or the main trunk of the tree, you have branches. We will worry about the name later. Like we're going to do kind of baby steps here. So we'll talk about the name later. But some of you might already see where the name comes from. Ethyl, methyl. We'll talk about that. We're getting there. Actually, we're going to get there now. So once you've identified the longest chain, then you need to look around. You need to look for functional groups, which we're not getting into today or for a long time. You need to look for double or triple bonds, not something we're going to do today. So for today, we're going to look for substituent groups. These are, the fancy definition is it's any atom or group of atoms that have replaced a hydrogen on the chain. And again, in simple words, guys, it's a branch. It sticks off of the parent. We number the continuous chain. Okay, actually, this is really important. We number the continuous chain in the direction that gives us the lowest possible numbers. Like you guys know in math class, when you're writing fractions, and in math, if you gave your math instructor the fraction 4 out of 10, your math instructor would be very upset because your math instructor would rather you write 2/5. Now, there's no math or fractions in this course, don't worry. But when I number the chain, I want to number it in a way so that the substituents, the branches, have the lowest possible numbers. And you will see me do this in a couple. Like we're going to do a bunch of examples here today. Now, we're starting off simple. What kind of branches will you see in this chapter? Sorry, guys. It's not COVID. Today I had a 2-hour lab, then 2 classes back to back, and then you guys. So I have been talking for at least 4 hours today. So it's I can't wait to finish. Anyways.
Okay.
Alkanes, yeah, these are alkanes, and these branches that you will typically see in nice and simple hydrocarbons. And I think you guys are going to like this course because I only choose normal, simple hydrocarbons, nothing crazy. We'll keep them small. So if you see one carbon sticking off of your parent chain, well, one carbon is called methane, right? Like CH4 is methane. But if it's a branch, we change it to methyl. And I don't have any reason why. I think it's just, it flows better, it sounds better, and it identifies to the reader that it is a branch or a substitute or substituent. Okay, what about 2 carbons? Well, 2 carbons is ethane. Well, we would call that ethyl. 3 carbons, propane, we call that propyl. 4 is butane, we call this butyl. After this, the branches become so long that they typically are part of the parent. So really, honestly, wink, wink, between the 13 or 14 of us, if you know these 4 branches, you are good to go for most of this course. Now, there are other branches like halogens, like chlorine, we would call that chloro. We'll talk about that later. But for today, if you guys can just keep these 4 words in the back of your mind, and I mean, arguably even these 3, we will make it. All right. So let's look at this. And this is a really cool question. Let me pick another color here. I'm going to pick purple. I'm feeling like a purple color right now. Look at this example. Now you'll notice the green, these are obviously not the parent chains. Okay, so let's really dive deep into this question. This is a really good molecule to look at. Let's just, okay, so what if this numbering, what if I'm wrong here? What if this is not the longest chain? Like, let's see if I'm correct. Okay, so what if I started here? 1, 2, 3. Okay, well, sorry. I could go 1, 2, 3. Now that's no good. No good. I could go 1, 2, 3, 4, 5, 6, 7. Okay, I could totally start here, but it's the same thing no matter what I do. This is like, again, this is a beautiful example. I could start here or I could start here. Either way, no matter where I start, on the second carbon, there will always be a methyl group sticking off of it. Does that make sense to everybody? Like if I did this, what I'm coloring in now, this is still a methyl group. So it doesn't matter where I start. So I want to start here. But what about the ethyl group? What about this guy? What if I started here? Let's see, 1, 2, 3, 4, 5, 6. No, that's no good. We don't want 6. We want at least 7. 1, 2, 3, 4, 5, 6. That's no good. So my longest chain is here on the bottom. Okay? Now.
So I have a question.
Yes, ask away.
If we start from the right to left.
Yeah.
Like, I know. From the right, it will be same or it will be different because the ethyl group will be on number 1, 2, 3, and the methyl will be on number 6.
Right. Okay. So you bring your question is, is perfect because this is what I was going to get into. The other thing, okay, to answer your question, if you started at the other side, you would be wrong. So why would you be wrong? And you kind of said it out loud. You would have different numbers. So like, okay, let's forget about these numbers here for a second. What if I started over here on the right? Okay, so 1, 2, 3, 4, 5, 6, 7. Now remember what I said on the last slide. We want to use the lowest possible numbers. So look up at the way it's originally named, 4 and 2. Here, it's 4 and 6. It's much preferred that you guys start on the left because it will give you the lowest numbers. Does that make sense?
Yeah, I got it. Yes, okay. I understood.
Cool. And guys, that was a question that you all need to understand, because if you did this on a test and you started numbering here and you had 4, okay, same, 4, fine. But 6, using the number 2 is better than the number 6. And if you did this wrong on a test, I would never, ever give you a 0. No way. You might lose half of a mark. I'm not crazy. If you've had me before, you know, well, maybe I might be crazy, but when I mark, I'm pretty fair. So, you know, there's no right or wrong answer. Like, you'll get part marks, don't worry. So let's just take a second now and look at this name. 1, 2. On the second carbon, I have a methyl group, 2-methyl. On the fourth carbon, I have an ethyl group. Now, let's see if anybody's thinking or if anybody has learned this before. Can anybody tell me why they think I did the 4-ethyl first and the 2-methyl second? Why did I put this first?
Because of the alphabet.
Yeah, beautiful. If you can't hear that, I'm clapping. And if you guys didn't hear what he said, alphabetical order. Now, again, guys, between us and I guess YouTube, it's not a big deal. So for me, it's not a big deal. It is a big deal. If you guys go on and do your chemistry degrees, chemical engineering degrees, and you don't follow these rules to perfection, you will not get full marks. You might even get a 0. I mean, my professors in university were insane. For me, As long as you follow some of the rules, I want low numbers. You need to name them right. You know, you can't call any of these like propyl. I'm okay. What I always told my students, if I can read your name and I can look at that name and draw the exact chemical, you will probably get full marks. The way you lose marks is if you number it wrong or you have crazy spelling mistakes, and I mean like crazy spelling mistakes, or if you have the wrong substituent. You know, if it's a methyl and you call it ethyl, you will lose a mark. So I'm pretty much done here. I'm going to read this rule, and then I'll go 2 quick examples, and then I'm going to save the other examples for you guys to maybe look at, maybe tonight or tomorrow if you're bored. Okay, we'll do them together, of course. So let me read these 2 slides. I'll quickly show you 2 examples, and halas, we are done, and I cannot wait. Okay, here we go. What do? How do you name alkane?
Mister,
Yes.
can you go back?
No, I'm kidding. Of course I can go. Yeah. Yes. What do you?
This one for the methyl. How you find? How do you say this is the methyl?
Yeah. How do I know it's methyl or methyl?
Yes.
Methyl? I think British people might call it methyl. That's a great question, and I kind of skipped over it. How do I know this is methyl and this is ethyl? Okay, so I'm going to color in my main chain. I'm really happy you asked that because I it's really important. Okay, so there's my main chain. You count the carbons sticking off of the main chain. So I don't care about this carbon on the bottom. Doesn't matter, okay? This chain has 1 carbon sticking off of it, right? Don't care about the chain. Don't count the carbons on the chain. So let me get another color here. Orange. These carbons don't get counted. Those carbons are on the parent chain. So how did I know it was methyl? Methyl is for 1 carbon. Ethyl is for 2 carbons. 1, 2. You see how it's bent? The bend tells me that it has 2 carbons. All right, does that make sense?
Yes, clear. Without counting the down one.
Yes, exactly. Yeah. And like just very quickly, because I do have to get going or my voice is going to die here. A methyl group looks like this. An ethyl group looks like this. Okay, oops, sorry. These are not real compounds, by the way. Okay, and what does a propyl group look like? What would 3 carbons look like? 1, 2, 3, like that. All right, so, oops. I didn't draw that as good as I could have. I have a computer program that draws these for me. And I have a free one that I'm going to tell you about soon. But there you go, methyl, ethyl, propyl. 1, 2, 3, 1, 2, 1. All right, here we go. Let me read, I want to read these, and then maybe I'll just do 1 or 2 of these, and that's it. All right, how do we put it all together? These 2 slides are really important, and I'm going to go a little fast because we're running out of time. I will come back to some of the harder rules like this one tomorrow or another day. We're going to keep it simple for today. So here we go. Step number 1, the parent, not step, but like, how do we write the name? Part 1. The parent is the last part of the name. The names of the substituent groups and where they are, we need to number them, like think of like a GPS situation. The name of the groups and the number of the carbon that they're on precede, which means goes in front of the parent name. You always separate numbers and the names with a hyphen. I'm going to show you this. I'll show you what I mean by hyphen. If 2 substituents are on the same carbon, the number of the carbon they are attached to is written before each name. What I mean is, if I had a methyl and an ethyl on number 2, I still write number 2. Okay, I write, I write 2-methyl, 2-ethyl. That you can't really have a 2-ethyl, but we'll get there, you'll see. Again, if this isn't making any sense, we will practice this tomorrow. We will practice this on Thursday. So if any of you are feeling overwhelmed or confused, like I'm at the very end of the class, we will come back to this tomorrow. This rule I'll do tomorrow. We're not going to do this one today. And then finally, I didn't see the name of the student, but somebody mentioned we always put the substituents, the branches, in alphabetical order. Okay, so let's just start with, oh, there is a typo. Look at my first typo. I'm going to fix that now because I can't fix that now. Sorry. Never mind. I can't fix it today. I'll fix it another day. My bad. Sorry. Let me share my slides again. But I see a typo there, which is secretly driving me crazy right now. But it's all good. It's all good. Everything's fine. This is fine, if you know that meme. This is fine. Sorry. Let me get my PowerPoint open again. All right. Okay. Sorry. One sec. Okay. There is a typo here. Maybe someone can tell me why that's a typo, but let's start with this one over here. Okay, my longest chain. 1, 2, 3, 4. 4 carbons. Okay, it could be 4 going this way too, but it doesn't matter. It really doesn't matter which way I number this, because no matter what, 1, 2, 3, 4. On the second carbon, I have another carbon. So this would have only 1 carbon up here. So we call that methyl. This is butane because it has 4 carbons. So we would say methylbutane. But you cannot tell me it's methylbutane without a number. I need a number. So this would be 2-methylbutane. This is again a weird example. You could probably get away without the 2 here, but that's a more complicated thing I'll talk about another day. So 2-methylbutane. Now, one thing, guys, and I'm almost done. What if I numbered this backwards? 1, 2, 3, 4. Now it would be 3-methylbutane. And I don't want that because I don't want the 3. I want the lowest number possible. So this is no good. Okay, almost done. I think you guys are checked out. I'm definitely checked out. So just give me 1 second here. I want to ask you guys, why is this wrong? What's wrong with that?
It's methyl.
Yep, methyl. I say methyl because of like my Canadian weirdness. If you say methyl, that's fine. I think that's what the British do, and the British are, the best. Well, they're not the best. They they like to say they pronounce everything properly. The British have pronunciation, and they would call it methane or methyl. Totally fine. So this student, you get 10 out of 10 for this test. It's methyl or methyl. This is only 1 carbon. It's methyl. My apologies. Do you have a question?
No, sir, no.
Okay, sorry, I didn't hear that. This would be hexane because it has 6 carbons. Sorry, my pen likes to tease me here. Okay. And it would be methyl because this is a methyl group. So this would be 3-methyl or methyl hexane. If I can teach here for another few years, You guys might, maybe my other students will start hearing me say methyl because everybody here says methyl. So I'm slowly changing how I speak. All right, so there you go, 3-methyl or 3-methyl hexane. Honestly, guys, if you're confused, if you're overwhelmed, we will do more examples tomorrow. Like practice, practice, practice. We're going to do so much practice. So come tomorrow. I'll see you in the lab at 7:30, and then I'll see you in class, I guess, on Wednesday. And yeah, that's it for me. So I'm going to kind of stop everything here now, and I will see you all in the lab, 7:30. Be on time tomorrow morning.